Hi there, this is Dr. Dell, and as you can see, I'm sitting here in the gazebo in the woods where we live. And the question has been raised by someone, what is mathematics? And so let me tell you a little bit about how I view it, what it is. Mathematics is essentially the study of numbers and the study of geometry. Now, numbers are things we use to count, things we use to measure things, and you all probably know a lot about numbers, counting numbers and numbers you use to measure. And geometry is about things like how long is something, or what's the area of something, triangles, circles, things like that. And that's really the basis of mathematics. It's all about that. And then mathematicians have developed a lot of tools now to study these subjects and to answer a lot of different questions that come up. And there's really basically two approaches to mathematics. One is a real down-to-earth, practical, kind of intuitive approach, kind of what you might say the real common sense approach. And the other approach is the theory approach. That's the approach where you're trying to make sure that you're not making mistakes. And I believe personally that the only way to really start learning math is with the practical approach, the down-to-earth intuitive approach. And so that's, of course, what we do in our program with practical math. We teach you these subjects from a very practical viewpoint. There's the practical approach. And I really think that's how you should start. Now, that means when you're solving problems, you're using solid reasoning, but you're not worried about the theoretical details. And once you've grounded yourself in practical math, and I believe that's how we should all start, that's how our ancestors started after all, then there comes a time when you want to approach math from a theoretical viewpoint. And what that means is you want to be sure that everything you do is exactly right. And so you create mathematical systems. And I'll talk about that on another video. What is a mathematical system for a theoretical mathematician? But that's much harder to do. And it's something that most people are really not going to ever be that interested in. That's getting into the theory of it. And it's fascinating. I love it myself. But it's not something you should present to people right off the bat. Unfortunately today, in many of the math classes that were taught, what I call the standard curriculum, the books that are normally used today in the United States at least in our high school level math, we tend to mix a lot of the theory in very early on. In fact, it's not uncommon to be teaching students a lot of theory at a very early age. And quite frankly, I think that's the wrong approach, because you're really not ready for theory until you have a grounding in the more intuitive, common sense math. And so that's my opinion, but I've been teaching math for many decades now, and I have found that if you postpone the theory until later on, it becomes much more understandable and absorbable, and indeed relevant for the people that care about it. Because if you're going to be a practical guy out here doing plumbing or hydraulics or carpentry or whatever, quite frankly, you're never going to care about the theory. You're never going to care what an irrational number is. You'll never use one, and you'll never need to know. And I'll talk a little more about that when we talk about the theoretical aspects of math.